Welcome to the deep dive. You're probably here because you want to get smart, fast on the stuff that really matters. And right now, in 2025, AI agents are just exploding. You hear about full task automation, a whole new way of doing things. So let's cut through all that noise. What are AI agents actually? And, how can understanding them give you a serious advantage?
Yeah, exactly. This isn't just like another piece of tech jargon. AI agents are, well, they're pointing towards a really fundamental change. Our goal today, give you a clear, straightforward picture of what makes them different, the main types you should know, and honestly why knowing this now is like getting a head start in a huge race. We've looked at a bunch of videos, articles, distilled it all down to the essentials for you. Think of it as your fast track to understanding something that could really shake up your year, maybe even beyond.
Okay, let's unpack that. So an AI agent, what is it? In simple terms, we hear it all the time, but how's it different from, say, ChatGPT or an image generator?
Right, so think of it like this. An AI agent is basically software that acts on its own, autonomously, to achieve goals. The really crucial difference from the AI tools you're maybe used to is that autonomy. It's not just sitting there waiting for your next command, It can actually take the initiative, solve problems, complete tasks. For you or for a system it's part of.
Autonomous. Got it. So more than just a fancy tool following my instructions to the letter, what else really sets them apart based on what we found?
Quite a few things, actually. First, you give them a goal, or they might even get one from another system, and then they figure out the steps to reach it. They look at their environment, could be the web, could be data, maybe even the physical world, and they make decisions based on what they observe. And importantly, they can learn. They adapt based on what they do, get better over time. Plus, many can connect with other tools, other APIs, even other agents. And often they just run in the background. No need for constant hand-holding.
That really does sound like a big step up. Our sources mentioned some specific examples, right? What are some of these agents we're actually seeing out there?
Yeah, there were some early ones, kind of foundational, like AutoGPT, AgentGPT, Baby AGI. They showed what was possible with autonomous AI. Then you've got things like Devin from Cognition Labs, the one they're calling an AI software engineer. It's designed to tackle complex coding projects pretty much by itself.
Wow.
And even things like ChatGPT. When you give it memory, let it use tools like browse the web or run code, it starts acting like a sort of semi-autonomous assistant. Oh, and custom GPTs too. If you set them up with the right tools, the right APIs, they can absolutely function as specialized agents for specific tasks.
Devin, the AI coder.
Yeah, that really underlines how serious this tech is becoming. Which brings us to the urgency, right? Why does this matter so much now, in 2025? It feels like something big is shifting. Absolutely. People are really seeing AI agents as the next evolution. Moving from AI that just responds to us to AI that can proactively collaborate with us. And the implications, they're massive across pretty much every field you can think of.
Can you give some examples? Where might we see the biggest impacts, really soon?
Okay, think about work. AI agents are starting to manage entire workflows, stuff that used to take people or even teams hours and hours. Be booking complex travel, doing deep market research, writing and testing code like we mentioned, even handling video editing from beginning to end.
Really? Video editing too?
Yeah, some demonstrations show that. And in software development, like with Devin, it could genuinely revolutionize how we build, test, maintain software. For businesses, agents could manage customer service inquiries, automate sales follow-ups, generate leads, run complex data analysis. Even in academia, research, helping with literature reviews, running simulations, organizing huge amounts of data. It's broad.
So, yeah, not just making things a bit faster, but potentially changing the whole game. The source has really hammered home that understanding this now is a real advantage.
Exactly. It's like any big tech shift, right? The people and organizations that get it, that adopt it early, they tend to benefit the most. If you're listening because you want to get knowledgeable quickly, focusing on AI agents right now puts you in a really strong position to leverage their power for your career, your business, or just to stay ahead.
Okay, so we get the what's and the why now. Let's dig into the different kinds of AI agents. That IBM technology video laid out a few types. Sounds like there's a spectrum from basic to pretty advanced.
Yeah, there is. And understanding these types helps make sense of what different agents can actually do and what their limits are. The most basic one they mentioned is the simple reflex agent.
Simple reflex, like a thermostat. Temperature drops, heat turns on, that kind of thing.
Perfect analogy. Exactly.
Wow.
A simple reflex agent works purely on a direct condition action rule. If this, then that, like your thermostat. If the temperature is below X, the condition, then turn on the heat, the action.
So it just sees something, reacts immediately based on a fixed rule, no thinking involved.
Pretty much. It takes in precepts. That's its sensory input, runs them against its internal if-then logic, and uses its actuators, how it affects the world, to do something. They're fine in really predictable environments, but they struggle if things get dynamic, and crucially, they have no memory. So they can't learn from past mistakes. If the same bad situation happens again, they'll do the same wrong thing.
Right, no learning loop. Okay, what's the next step up from that?
That would be the model-based reflex agent. It's more advanced. It still uses those condition action rules. But the key difference is it also maintains an internal model of the world, a sort of stored understanding of how things are.
An internal model. So, like, it remembers stuff, it has a sense of the state of things.
Exactly. It keeps track of how the environment is or how it thinks it is based on past observations. And crucially, it understands how its own actions affect that environment. So it's not just reacting blindly to what it sees right now. It uses this internal model to make decisions. Think of a robot vacuum cleaner, one that maps your room.
Ah, yeah. It knows where it's already clean, where the furniture is.
Right. It uses its model to remember that. It knows moving forward changes its position on its internal map. It can even infer things about parts of the room it can't currently see.
Okay, so it has some awareness and memory. What comes after model-based?
Next up, you have goal-based agents. These build on the model-based idea, but their decisions are driven by explicit goals, desired outcomes. The question shifts from what action matches this condition to what action will get me closer to achieving my goal.
So it's actually thinking ahead, trying to reach a specific target state.
Precisely. It uses its internal model to simulate, okay, if I do action A, what's the likely outcome? Does that move me towards my goal? What about action B? It predicts the consequences. A self-driving car trying to navigate to a destination is a classic example. It constantly plans sequences of actions: turn left, accelerate, brake based on which sequence it predicts will best lead to the final address. These are used a lot in robotics, simulations, anything with a clear objective.
That seems like a much more intelligent way to operate, but there are more types. Utility-based, what's that?
Right, utility-based agents, they take it even further. They don't just look at whether an action achieves the goal, but how good or desirable that outcome is. They think about utility.
Utility, like happiness points or something?
Kind of, yeah. It's a measure of preference. So maybe there are multiple ways to reach the goal, but some ways are better than others, faster, safer, more efficient, whatever. A utility-based agent evaluates the expected utility of different potential future states. It ranks the options based on how desirable they are overall.
Okay, so not just any path to the goal, but the best path, according to some criteria.
Exactly. Think about an autonomous delivery drone. A goal-based agent might just find a route. A utility-based agent would try to find the route that's maybe fastest, uses the least battery, and avoids flying over restricted areas. It optimizes for maximum utility, considering multiple factors.
Makes sense. It's about finding the optimal solution, not just a solution. And the final type, the most advanced.
That's the learning agent. These are the most adaptable because, well, they learn from experience, they get better over time. They don't just rely on pre-programmed rules or fixed goals. They actually adjust their behavior based on feedback.
How does that learning actually work? What's inside a learning agent?
Usually there are a few key components working together. There's a critic, which looks at what the agent did and compares the outcome to some standard of performance. It provides feedback, often called a reward or penalty. Then there's the learning element. It takes that feedback from the critic and uses it to update the agent's internal knowledge, basically, improving its decision-making process for the future. You also often have a problem generator, which is interesting. It suggests new exploratory actions, things the agent hasn't tried before just to see what happens, helps avoid getting stuck in a rut. And finally, the performance element, which is the part that actually chooses the actions to take, based on what the learning element currently knows.
So it's like a cycle. Act, get feedback, update knowledge, maybe try something new, act again.
Exactly. Think of an AI playing chess or Go. It makes moves, performance element, sees if it won or lost, critic feedback, adjusts its strategy, learning element, and maybe tries unconventional openings sometimes, problem generator.
Very cool. Sounds a lot like how humans learn, actually.
It definitely mirrors that process. Now, the trade-off is that learning agents can be slower, need more data, more computation. Oh, and the IBM video also quickly touched on multi-agent systems.
Right, where you have multiple agents working together.
Operating in the same environment, maybe collaborating on a common goal, or maybe even competing. That adds another whole layer of complexity and potential.
Okay, that's a helpful breakdown of the types. Now, Jeff Su's video offered a different angle. comparing agents to LLMs and workflows using levels. Can we walk through that? Seemed like a good way to clarify things.
Yeah, Jeff Su's levels analogy was really useful. He started with level 1, large language models, LLMs, your basic ChatGPT, Gemini, Claude, etc. You give them text, they give you text back based on their training. Simple input, output, ask it to draft an email, address an email. But you pointed out the limitations, right? They don't know your private info, your company data, unless you paste it in. And they're passive. They wait for you.
Right. You have to prompt them for everything. So what's level 2?
Level 2 is AI workflows. This is where humans define a specific step-by-step path for the LLM to follow. You basically chain commands together. So maybe you set up a workflow. Step 1, search my calendar for free slots. Step 2, draft an email suggesting meeting times. The LLM follows your instructions. Retrieval augmented generation, or RAG, where the model looks stuff up first, that fits here too. It's still following a predefined process you set up.
Okay, so it can do more complex things by following my script, but I'm still the director. I'm making the decisions about the step.
Exactly. You are the decision maker. He gave that example of creating social media content. Maybe a workflow finds news articles, summarizes them, drafts posts, schedules them. That's automation.
Yeah.
But if the posted drafts are kind of dull, you have to go back, tweak the prompts, maybe change the workflow steps. The human handles the iteration and improvement.
Ah, okay, so the human is still the one reasoning about how to make it better. Which leads us to level 3. AI agents. This is the big jump.
This is the big jump. Level 3 is AI agents. The absolute key difference, Jeff emphasized, is the LLM itself becomes the decision maker. It replaces the human in figuring out the how. You give it a goal, and the agent reasons about the best way to achieve it. It decides which tools to use, what actions to take, in what order, autonomously. This is that crucial reason and act cycle he talked about.
Okay, so back to the social media example. An agent wouldn't just follow my steps, it would figure out what steps to take.
Yes, it might decide, okay, to grow engagement, I need to analyze top-performing posts in this niche. Then I'll find relevant trending news. I'll generate 5 different post variations using the summarization tool. Then I'll use the analytics tool to predict which one will do best. Then I'll schedule it. It figures out that whole chain itself. It might even critique its own output and refine it before scheduling, without you defining every single step. He mentioned that Make.com example, where an agent decides how to compile links, maybe use sheets, maybe a database, and which tools to use. And that AI vision example, identifying a skier in a video without labels. That's the agent reasoning about skierness and then acting to find it. Total game changer.
That autonomous reasoning and acting. Yeah, that's a huge difference. Now, David Andresian's video was interesting because it showed that building these agents isn't necessarily just for hardcore coders anymore, right?
Yeah.
Using platforms like 1EN.
Absolutely. David Andres really made the point that tools like AnyN are making agent building much more accessible, even if you're not a developer. It's becoming more of a low-code or even no-code thing in some cases. He did stress, though, that for an agent to be really useful, it often needs to run 21/7. So he mentioned needing to host it somewhere, suggesting hosting her as one user-friendly option for deploying AnyN.
Right, because you want it working in the background, monitoring things, or taking action whenever needed.
Exactly. You don't want it to only work when your laptop is open. He then walked through building a simple AI accountant agent in NAN. The first step was the trigger, setting it up to watch a Gmail account for new emails.
Okay, and connecting Gmail sounded like it had a few setup steps.
Yeah, there's a bit of initial config needed in Google Cloud. You have to get credentials, like a client ID and secret, set up permissions so NAN can actually access the mailbox securely. David acknowledged it's a hurdle, but kind of a one-time thing you need to do to give the agent the power to, act on your emails. Once connected, he showed fetching a test email just to make sure the link was working.
Okay, connection made. Then the agent part comes in.
Right. He used the specific AI agent node within NAN. The tasks for this agent: figure out if an email is a receipt or an invoice. So he wrote a prompt telling the agent what to look for, keywords in the subject, the sender, the email body, and, importantly, he gave it a system prompt to guide its output.
Yeah.
Just say yes if it's an invoice receipt, no if it's not. Keep it simple. Then you connect it to an actual AI model, like OpenAI's models, by plugging in your API key.
So the NAN node uses the power of something like GPT-4 to understand the email content and make that yes-no decision.
Exactly. It leverages the LLM's understanding of language to classify the email based on the instructions. After testing that part, he added a switch node.
Like a fork in the road for the workflow.
Precisely. If the AI agent output yes, it's an invoice, the workflow goes down one path. If no, it goes down another, or maybe just stops. For the yes path, the invoice path, the next step was to actually get the invoice file, assuming it was an attachment.
How did it grab the attachment?
It used another NAN node, the getMessage function again, but this time told it specifically to download attachments. Then, the workflow sent that file to Google Drive. He showed configuring the Google Drive node, telling it which data field held the file, like attachment 0, using an expression to name the file dynamically based on the email subject or sender, connecting his Google Drive account, and picking the exact folder to save it in.
And he showed the whole thing working. Email comes in, agent says yes, attachment gets saved to Drive.
Yep, the full end-to-end. Invoice hits Gmail, the NAN workflow triggers, the AI agent node classifies it, the switch directs it, the attachment gets pulled and lands neatly in the designated Google Drive folder, all automatic. It was a great practical example of the kind of efficiency gains you can get, saving loads of manual effort.
Really powerful to see it laid out like that. Now, shifting gears slightly, the Google Cloud article gave a good wrap-up of the core capabilities and also the challenges. What were the main things they highlighted?
Yeah, it was a good summary. They boiled down the key capabilities of agents to reasoning, using logic to figure things out, actually doing things in their environment, observing, gathering info, planning, making strategic plans, collaborating, working with humans or other AIs, and self-refining, that crucial ability to learn and adapt.
Those all really reinforce that autonomy and intelligence we've been talking about. Did they also clarify how agents differ from, say, assistants or just simple bots?
They did. The main differentiator, again, is autonomy. Agents are highest on that scale, making independent choices. Assistants usually need more human direction. And bots, they're typically at the bottom, just following rigid scripts. They also mentioned agents usually tackle more complex tasks and often use machine learning to improve, whereas simpler bots might not learn at all.
Okay, but they're not magic, right?
Yeah.
What about the limitations or challenges mentioned?
Definitely not magic yet. The article pointed out that tasks needing deep human empathy or complex emotional understanding. Still really hard for agents. Situations with high ethical stakes are also tricky. Agents don't have inherent morality like humans do. Navigating really unpredictable physical environments can be tough. And some agent applications can just require massive amounts of computing power, which is a practical constraint.
So, powerful, yes, but there are still boundaries. Good to keep in mind. But the potential uses they listed were still super broad: customer service, employee productivity, creative stuff, data analysis, code, security.
Absolutely. It really paints a picture of agents becoming embedded across almost everything we do professionally and maybe even personally.
Okay, so for listeners who are now thinking, right, I need to get up to speed on this, what resources did our sources suggest? Where can people start learning or playing around with this stuff?
There are definitely pathways in. For beginners, just getting a feel for it, YouTube channels like Matt Wolf or Future Tools are great for seeing demos and getting ideas. Searching how to use AI agents in 2025 is a good starting point too. For more structured learning, there are free courses from places like deeplearning.ai. And even just reading the documentation for frameworks like LangChain can teach you a lot. Oh, and keeping up with newsletters or blogs like Ben's Bytes or the Rundown AI is key because this space moves so fast.
Right. And what about actually trying some agents out, maybe without needing to code?
Yeah, several platforms were mentioned for that. AgentGPT and AutoGPT let you experiment with setting goals for autonomous agents. ChatGPT Pro itself, with tools and custom GPTs, lets you build agent-like capabilities. FlowiseAI offers a visual way to build agent workflows, kind of drag and drop. And CrewAI is interesting for setting up teams of agents that can collaborate. Lots to play with.
And for the more technically inclined?
The developers listening. For them, the core tools are things like the LangChain library, which is huge. The OpenAI API, obviously, for the language model brains. Microsoft's AutoGPT framework is popular for multi-agent setups. Hugging Face's Transformers library gives access to tons of models. And fundamentally, knowing Python is pretty essential for gluing all these APIs and libraries together to build custom agents.
Okay, so entry points exist whether you're technical or not. That's good. Now let's talk about the flip side. The sources were pretty clear that ignoring AI agents right now could be, well, risky. What are people potentially missing out on?
Yeah, the message is pretty strong. You risk missing huge productivity gains, basically, letting agents handle the grunt work while you focus on higher level stuff. Competitively, both for individuals in their careers and for businesses, you risk falling behind. Others will be using these tools to work faster, smarter, maybe even create entirely new business models. You might just find yourself bogged down, lacking time freedom because you're still doing the repetitive tasks that could be automated. It's also about missing that early adopter advantage. Think of people who were slow to adopt the internet or smartphones. And frankly, it could impact earning potential. People leveraging AI effectively are likely going to be more valuable in the job market. It's becoming a key skill.
So the takeaway really is don't sleep on this. It's not just hype.
Not anymore, it seems. Learning to work with AI agents in 2025 is looking less like an option and more like, well, like learning to use email or search engines. It's becoming fundamental. The potential is there to make you faster, smarter, give you leverage you didn't have before.
Okay, so as we wrap up this deep dive, what's the final thought we should leave listeners with? Something to mull over.
Maybe this. Think about your own day, your own work. What's one task, maybe two, that eats up your time but doesn't necessarily require your unique human creativity or judgment? Now, picture an AI agent handling that task for you, autonomously. What would you do with that freed up time and mental energy? That's the promise right there. So maybe dip your toe in, check out some of the resources we mentioned. Even just understanding the potential is a huge first step. Because this era of intelligent, autonomous agents, it's not coming, it's here. And figuring out how to navigate it is becoming pretty essential.
We've covered a lot today, what AI agents are, the different types, why they matter so much right now, how you can start building them, and what resources are out there. We hope this gives you a solid foundation and maybe sparks some ideas about how these powerful tools could impact your own world. Definitely worth exploring further.